Next, we will look at an organic molecule. When we see an oxygen in a molecule, such as we see here with the carbonyl or the C double bond O group, that is a good indicator that we're dealing with a polar molecule. Remember that the carbon-carbon bonds will all be nonpolar because they're the same element, and carbon-hydrogen bonds are also nonpolar. This will have dispersion forces, as do all molecules. It's a polar molecule, so it has dipole-dipole forces. For hydrogen bonding, we need to see where our hydrogens are attached, so we can add in our implied hydrogens, and what we see is that all of the hydrogens in this molecule are attached to carbon atoms. Therefore, we do not meet the definition for hydrogen bonding. No ions, so no ion dipole or ionic forces. In pentane, we have only carbon-carbon bonds and carbon-hydrogen bonds. These are all nonpolar bonds, therefore we will have a nonpolar molecule. As a result, we will only see dispersion forces. This molecule is known as propanol. It's an alcohol. The presence of the OH and the CO bonds will result in some polarity for this molecule. So we will see dispersion forces, dipole-dipole forces. When we look at our definition of hydrogen bonding, we need a hydrogen attached to a fluorine, oxygen, or nitrogen, and we see that we meet that definition, so we will also have hydrogen bonding, and no ion dipole or ionic forces. The reason we worry about intermolecular forces is because they affect the properties of substances. These effects are most evident in the boiling and melting point, in particular the boiling point of a substance. Remember that boiling is the phase change from liquid to gas. As a result, we are moving those molecules farther apart from one another in the gas phase than they were in the liquid phase. And what we find is the stronger the intermolecular forces, the higher the boiling point. Let's look at some molecules to compare and determine which has the highest boiling point. Note that we will not look at specific values, but we will just be able to compare what is higher and what is lower. Our first two molecules are alkanes, and as a result are nonpolar molecules, and they only have dispersion forces. Remember, dispersion forces are the weakest of the intermolecular forces. When we look at the two alcohols, we see that these are polar molecules. They will have dispersion forces, dipole-dipole forces because of the polar molecule, and hydrogen bonding because we have the hydrogen attached to an oxygen. The lower two will have a higher boiling point than the top two because they have stronger intermolecular forces. When comparing the two alcohols, we can also see that everything is the same except for the number of carbon and hydrogen atoms. Because they each have one OH group, their hydrogen bonding is relatively the same strength. The polarity is about the same, so the dipole-dipole forces are comparable to one another. The thing that will differentiate these two are the dispersion forces. Because the bottom molecule has more atoms, it has more electrons, and therefore more dispersion forces. So that's what makes the difference between the bottom two to determine that the bottom molecule has the highest boiling point. The lowest boiling point of the four would be the propane molecule at the very top. Which substance will have the highest boiling point? First, we want to identify which molecules are polar and which ones are nonpolar. A has an OH group, which makes the molecule polar. B contains only carbon-carbon and carbon-hydrogen bonds, so it will be nonpolar. And C has OH groups, so it will also be polar. Because we are looking for the highest boiling point, we can eliminate B as a choice because it is nonpolar and has only dispersion forces. In comparing A and C, we see that A has one source of hydrogen bonding with the one OH group, and C has two sources of hydrogen bonding because it has two OH groups. As a result, the hydrogen bonding will be stronger in C than in A, and this will lead to C having the highest boiling point.